जैसे इस फिगर में टेबल में देखें 3.3 में देखें वेरियस कॉन्सेप्ट ऑफ कॉस्ट जैसे दिया हुआ है इनपुट 1 2 3 4 ऐसे करके पूरा 10 तक दिया हुआ है। टोटल फिक्स्ड कॉस्ट जो सेम रहेगा TVC जो टोटल वेरिएबल कॉस्ट जो ये बढ़ रहा है ना, और टोटल कॉस्ट जो है आपका वो भी बढ़ रहा है। ठीक है, अब एवरेज फिक्स्ड कॉस्ट तो वो धीरे धीरे घटेगा क्योंकि आउटपुट बढ़ रहा है आपका, और बस और वो फिक्स्ड है तो वो घटेगा ही। एवरेज वेरिएबल कॉस्ट जैसे देखने के पर जीरो आउटपुट पे तो जीरो ही होगा, डैश कुछ नहीं होगा। और उसके बाद जो है एवरेज शॉर्टन एवरेज कॉस्ट वो आपका जैसे हो गया टोटल कॉस्ट हो गया ना, टोटल कॉस्ट 30 हो गया, उसमें डिवाइड किए तो वो हो गया 30 डिवाइड बाई 1 किए तो 1 हो गया। और तो शॉर्टन मार्जिनल कॉस्ट क्या होगा, शॉर्टन मार्जिनल कॉस्ट जैसे 30 में से ये वेरिएबल 30 में से 20 घटाएंगे तो 10 होगा। इस तरह से डिवाइड करते करते हम लोग इस तरह पहुंच जाएंगे। तो जैसे एवरेज वेरिएबल कॉस्ट भी मतलब हम लोग क्या समझ रहे हैं इस फिक्स से, टोटल कॉस्ट तो फिक्स रहेगा, एवरेज फिक्स्ड कॉस्ट वो घट रहा है क्योंकि आउटपुट नीचे जो डेसिमल जो नीचे में जो है डिवाइड वाले में है तो वो तो बढ़ रहा है, तो इसके कारण ये घटते जा रहा है। एवरेज वेरिएबल कॉस्ट ये पहले बढ़ रहा था फिर घटे जा रहा है घटे जा रहा है घटे जा रहा है, फिर यहाँ पे बढ़ जा रहा है क्योंकि एक लिमिट होता है किसी भी चीज़ का फिक्स्ड कॉस्ट का, तो ये फिर बढ़ने लगा। ठीक है, मतलब फिर शॉर्टन एवरेज कॉस्ट अगर हम देखें तो भाई टोटल कॉस्ट को डिवाइड कर देंगे आउटपुट से, फिर ये भी घटे जा रहा है, फिर एक भी बढ़ रहा है। फिर शॉर्टन मार्जिनल कॉस्ट देखेंगे तो मतलब लास्ट वाले से यूनिट से, जैसे फर्स्ट यूनिट को सेकंड यूनिट से, तो वो ये दिख रहा है कि मार्जिनल कॉस्ट भी घट रहा है, लेकिन एक लेवल के बाद ये सब बढ़ने लगेगा, है ना। जस्ट लाइक the case of marginal product, marginal cost also is undefined at the level of output. It is important to note that in the short run, fixed cost cannot be changed. When we change the level of output, whatever change occurs to total cost is entirely due to the change in the total variable cost. So in the short run, marginal cost is the increase in total variable due to increase in production of one extra unit of output. For any level of output, the sum of the marginal cost up to that level give us the total variable cost to that level. One may wish to check from the example represented through chapter 3.3. Average variable cost at the some level of output is therefore the average of all marginal costs up to that level. In table 3.3 we see that the when the output is 0, certain marginal cost is undefined. For the unit for the first unit of output, shorter marginal cost is rupees 10. For the second unit, shorter marginal cost is 8, and so on. Shape of the short run marginal cost curve. Now let us see what this short run cost curve look like. You could not plot the data in table 3.3 by placing the output on the x-axis and cost on the y-axis. Previously we have जैसे ये देख रहे हैं शॉर्ट रन तो कॉस्ट बढ़ रहा है तो टोटल वेरिएबल कॉस्ट भी बढ़ रहा है, टोटल कॉस्ट भी बढ़ रहा है। तो TFC जो है टोटल फिक्स कॉस्ट वो तो एकदम हॉरिजॉन्टल ही रहेगा, है ना। प्रीवियसली we have discussed that in order to increase the production of the output, the firm need to employ more of the variable input. This result in the increase in total variable cost and hence an increase in total cost. Therefore, as the output increase, the total variable cost and the total cost increase. Total fixed cost, however, independent of the amount of output produced and remain constant at all level of the production. Figure 3.3 illustrates the shape of the total cost, total variable cost, and the total cost curve for a typical one. We place output on x-axis and the cost on the y-axis. TFC is a constant which takes the value of C1 and does not change with the change in output. It is therefore a horizontal straight line cutting the cost axis at the point C1. At Q1 TVC is C2 and TC is C3. AFC is the ratio of TFC to Q. TFC is constant. Therefore, as the Q increases, AFC decreases. When output is close to 0, AFC is arbitrarily large and the output move toward infinity. AFC move toward 0. AFC move toward 0. AFC curve is in fact a rectangular hyperbola. If we multiply any value of Q of the output with this corresponding AFC, we always get a constant, namely TFC. Figure 3.4 show the shape of the average fixed cost curve for a typical firm. We measure the output along the horizontal axis and AFC along the vertical axis. At Q1 level of output, we get the corresponding average fixed cost at F. The TFC can be calculated. TFC equal to AFC into quantity equal to OF into OQ1. OF into OQ1. The area of rectangle is OFCQ1. The area of rectangle equal to OFC1. We can also calculate the AFC from TFC in TFC curve. In figure 3.5, the horizontal straight line cutting the vertical axis at F is the TFC curve. At Q0 level of output, the total fixed cost is equal to OF. At Q0, the corresponding point on the TFC curve is I. Let the angle is AOQ be theta. The AFC Q0 is AFC equal to TFC by quantity. AQ0 equal to 0, OQ0 equal to tan theta. Let us look at the SMC. Marginal cost is the horizontal cost that a firm occurred to produce one extra unit of output. According to the law of variable proportion, initially the marginal product of a factor increase as employment increase, then after a certain point it decrease. This means initially to produce extra unit of output, the requirement of the factor become less and less, and then after a certain level it become greater and greater. As a result, with the factor price given, initially the SMC fall, and then after a certain point it rises. SMC curve is therefore U-shaped. At 0 level of output, SMC is undefined. The TVC at a particular level of output is given by the area under the SMC curve up to that level. Now what does the AFC curve look like? For the first unit of output, it is easy to check that SMC and the AVC are the same. So both the SMC and the AVC curve start from the same point. Thus as the output SMC fall, ABC being the average of the marginal cost also fall, but fall less than the SMC. Then after a point, SMC start rising. ABC however continue to fall as long as the value of the SMC remain less than the prevailing value of ABC. Once the SMC has risen sufficiently, its value become greater than the value of ABC. The ABC then start rising. The ABC curve is therefore U-shaped. As long as the ABC is falling, SMC must be less than the ABC. As ABC rises, then C must be greater than ABC. So the SMC curve cut the ABC curve from the below at the point of ABC. In figure 3.7, we measure output along the horizontal axis and TVC along the vertical axis. At Q level of output, OV is the total variable cost. Let the angle EOQ be equal to theta. Then at Q, The AVC can be calculated as AVC equal to TVC by output. EQ0 equal to OQ0 equal to tan theta. In figure 3.6, we measure output along the horizontal and AVC along the vertical axis. At Q level of output, AVC is equal to OP. The total variable cost is Q0 is TVC equal to AVC into quantity, OV equal to OV into OQ0. The area of the rectangle OV BQ0. Let us now look at SAC. SAC is the sum of AVC and initially both AVC and the AFC decreases as the output increase. Therefore, as SAC initially fall after a certain level of output of production, AVC start rising, but AFC continue to fall. Initially, the fall in AFC is greater than the rise in AVC, and SAC is still falling, but after a certain level of production, the rise in AVC become larger than the fall in AFC. From this point onward, SAC is rising, and the SAC curve is therefore U-shaped. It lies above the AVC curve with vertical difference equal to the value of AFC. The minimum point of the SAC curve lies to the right of the minimum point of the AVC curve. Similar to the case of the AVC and the SMC, as long as the SAC is falling, SMC is less than the SAC. When the SAC is rising, SMC is greater than SAC. SMC curve, the SAC curve from below at minimum point of SAC. Figure 3.6 shows the shape of the shortened marginal cost, average variable cost, shortened average cost for a typical firm. AVC reaches its minimum at Q1 unit of output. To the left of Q1, AVC is falling and SMC is less than AVC. To the right of Q1, the AVC is rising and the SMC is greater than AVC. SMC curve cut the AVC at point P, which is minimum point of the AVC curve. The minimum point of the SAC curve is S, which correspond to the output Q2. It is the intersection point between the SMC and the SAC. To the left of the Q2, SAC is falling and SMC is less than the SAC. To the right of Q2, SAC is rising and the SMC is greater than the SAC. Long run cost. In the long run, all the input are variable. There are no fixed cost. The total cost and the total variable cost therefore coincide in the long run. Long run average cost is defined as the cost per unit of output. Long run average cost is equal to TC by Q. Long run marginal cost is the average in the total cost per unit of change in output. When the output changes in discrete unit, if we increase the output from Q1 minus 1 to Q1 unit output, the marginal cost of producing Q1 unit will be measured at long run marginal cost equal to TC at Q1 unit minus TC at Q1 minus 1 unit. Just like the short run, in the long run, the sum of the marginal cost up to the some output level give us the total cost at that level. Shape of the long run cost curve. We have previously discussed the return to scale. Now let us see the implication for the shape of long run average cost. IRS implies if we increase all the input by a certain proportion, output increase more than that proportion. In other words, to increase the output by a certain proportion, input need to be increased by the less than the proportion. With the input price given, cost also increases by the lesser proportion. For example, suppose we want to double the output. To that, the input need to be increased, but less than double. The cost at the firm incur to hire those input, therefore also need to increase by less than the double. What is happening to the average cost here? It must be in the case as long as the IRS operate. Average cost fall as the firm increases output. DRS, decreasing, it implies if we want to increase the output by a certain proportion, input need to be increased by more than the proportion. As a result, the total cost also increased by more than that proportion. So long as the DRS operate, the average cost must be rising as the firm increases output. CRS implies a proportional increase in input resulting in proportional increase in output. So the average cost remain constant as long as the CRS operate. It is argued that in the typical firm, IRS is observed at the initial level of production. This is then followed by the CRS and then by DRS. Accordingly, the LRAC curve is U-shaped. It is downwards a sloping part corresponding to IRS, upward rising part corresponding to DRS. At the minimum point of the long run average cost curve, CRS is observed. CRS is the minimum point of the long run average cost curve. CRS is observed. Let us check how the long run marginal cost curve look like. For the first unit of the output, both a long run marginal cost and long run average cost are same. Thus, at the output in long LRAC initially fall. Then after a certain point, it rises as long as the average cost is falling. Marginal cost must be less than the average cost. When the average cost is rising, marginal cost must be greater than the average cost. Long run marginal cost curve is therefore U-shaped curve. It cut the long run average cost curve from below at the minimum point of the long run average cost. Figure 3.9 show the shape of the long run marginal cost curve and the long run average cost curve for a typical firm. Long run average reaches its minimum point at Q1. To the left of Q1, long run average cost curve falling and long run marginal cost is less than the long run average cost curve. To the right of Q1, long run average cost is rising, long run marginal cost is higher than the long run average cost. For different combination of input, the production functions show the maximum quantity of output that can be produced. In the short run, some input cannot be varied. In the long run, all the input can be varied. Total product is the relationship between a variable input and the output when all other input are held constant. For any level of employment of input, the sum of the marginal product of every unit of the input up to that level give the total product of that input at that employment level. Both the marginal product and the average product curve are inverse U-shaped. The marginal product curve cut the average product curve from at the maximum point of the average product curve. In order to produce output, the firm chooses least cost combination. Total cost is the sum of the total variable cost and total fixed cost. Average cost is the sum of the average variable cost and the average fixed cost. Average fixed cost is downward sloping. Short run marginal cost and average variable cost and short run average cost curve are U-shaped. SMC curve cut the average variable cost from below at the minimum point of ABC. SMC curve cut the short run average cost curve from below at the minimum point of the SSA. In the short run, for any level of output, sum of the marginal cost up to that level give the total variable cost. mm, the area under the SMC curve up to that level of the output give the total variable cost to that level. Both LRAC and long run marginal cost shape are U-shaped. Long run marginal cost curve cut the long run average cost curve below at the minimum at long run average cost curve. Thanks for watching.